Okay guys, I'm going to continue with our lessons on solving equations from where we had left off. In your MathLinks textbook we had gotten to the end of section 8.2, which was solving equations involving two steps in order to undo our process to get our variable. So today we're going to look at using the distributive property. Now remember the distributive property, we talked about that when we were multiplying polynomials. So it would be like having something like 5 times 2d plus 3. So remember the distributive property, what we're doing is we're taking that number in front of the brackets and we are multiplying everything inside the brackets by that number out front. So this would mean if I've got 5 times 2d plus 3 in the brackets, I'm working with 5 times 2d as well as 5 times 3. Okay, so each thing inside the brackets is multiplied by what's in front. So that 5 times 2d becomes 10d, and the 5 times 3 would become 15. Okay, so what I'm going to do now is I'm going to change that. Instead of just being an expression on its own, I'm going to turn this into an equation by saying on the other side it equals negative 25. And I'm going to carry that through. Again, keeping your equal signs nice and lined up. So now what I've done is I've taken this question, which had distributive property, and I've made it a two-step equation. Okay? So just like we've been practicing, we're going to undo our operations by removing the constant first from both sides. So I'm going to subtract my 15 from both sides, because subtracting 15 is the opposite of adding 15. These guys now cancel one another on this side, and we're left with 10d on the left, and on the opposite side we have negative 40. Okay? Now to isolate the variable we need to divide both sides by 10, and when we divide both sides by 10, on the left hand side our 10s cancel one another out, and we get that d is equal to, on the other side, negative 40 divided by positive 10 gives us negative 4. Okay, so using distributive property, we simply remove the brackets, multiply everything inside the brackets by what was out front. That gives us now our equation, and we solve as we've been doing. Okay, so I'm going to take it up one level. Let's look at some examples involving some more difficult numbers. Okay, so I've got, now we're going to solve and verify 6 times x plus 0.4 is equal to negative 7.8. Okay, so my first step is going to be multiply that 6 in front of the brackets inside. So everything is going to get multiplied by that 6 in front. So 6 times x is going to give me 6x. 6 times 0.4 is going to give me positive 2.4, and that equals negative 7.8 on the other side. Okay, so now my opposite is going to be subtracting 2.4 from both sides, and that gives us 6x is equal to negative 10.2. Okay, and then we're going to divide both sides by 6. Okay, and that leaves us with x. So we've got negative divided by positive, and that's going to give us something negative. And then 10.2 divided by 6 is 1.7. Okay. All right, so that's going through and solving. So the verifying, remember that means we got to check that our answer is correct. So it means I should be able to take that value we just got for x and put it back into our equation. So I'm going to rewrite everything as it started. So I'm going to go back, I'm going to put the brackets back like they were. Okay, so go back to the equation before you started messing around with it. Okay, I'm going to substitute, instead of x, I'm going to fill in our negative 1.7. And remember, when you substitute, put it in brackets to keep everything nice and separate. So instead of using distributive property here, I now have an operation inside the brackets that I can complete. So I've got 6 times, and inside the brackets I have negative 1.7 plus 0.4, When I add those two things together, I have more negatives than I have positives, so I'm going to have negatives left over, and negative 1.7 plus 0.4 gives me 1.3. Okay, so now I'm going to multiply the 6 times the negative 1.3, and that gives me negative 7.8, which is good. That's what I was hoping for. We want to get the same value on both sides. All right. Now, there is another way to solve this question. So I'm going to do the exact same question, but I'm going to show you a different way of solving it. When my first step was to multiply inside the brackets, but I can also think of going backwards through my order of operations, right? So if I was going backwards through my order of operations, I would add the 0.4 to the x first because it's inside of the set of brackets. And after we've done that, we would multiply by 6. If I'm going to go backwards to solve for my variable, I can actually get rid of that multiplication first. So I'm going to divide on both sides by 6. Okay, so instead of multiplying that 6 into the brackets, I can divide both sides by 6. My 6's here are going to cancel one another. So what I have now is my x plus 0.4, and they're all alone now. The brackets are gone because I'm going to multiply 1 and divide by 1. So x plus 0.4 is going to stay exactly the way it was. Okay. On the other side, we've got our 7.8 divided by 6. Negative divided by positive gives us a negative 1.3. And now my opposite is to simply subtract 0.4 from both sides. These 0.4s here cancel out, and I'm left with x is equal to negative 1.7. Okay, I got the exact same answer as what I had on the last slide. You're allowed to pick whichever method is easier to you. If you want to get rid of the brackets by using distributive property first and then doing a two-step equation to solve, it will work just fine. If you'd like to get rid of that number in front of the brackets, simply divide both sides by that coefficient in front of the brackets and it'll go away. All right. Okay, one more. Again, we'll increase the difficulty a little bit and bring in everybody's favorite, fractions. Here we go. Remember, fractions are friends. Now again, from when we were multiplying and dividing polynomials, okay, my first step, if I'm going to use distributive property, is that everything in this fraction is being divided by my denominator of 3. So each thing is divided by that 3 separately. So this is going to become t over 3 minus 5 over 3. So each term up top is divided by that denominator. Okay? So now I've got t over 3 minus 5 over 3 is equal to 5 over 4. My opposite now is to add the constant on both sides. So that means I need to add 5/3 to both sides, leaving me on the left-hand side with t over 3. And on the right side here, I'm going to take this. I can't see what that answer is right off the top of my head. I need a common denominator for 4 and 3. My common denominator would be 12. In order to get that, I'm going to multiply top and bottom on the left by 3, giving me 15 over 12. On the right-hand side, I'm going to multiply both by 4 in the numerator and denominator, and that gives me 20 over 12. Okay? In total, now I have 35 over 12. So I'm going to bring that answer back down here, 35 over 12. Remember, do your work off to the side, otherwise you get a real jumble of work going on in your equation and you might get lost. Okay? All right, so now that I've got t over 3 is equal to 35 over 12, I got to get rid of that 3. So remember, when we're working with fractions, I know a lot of you guys, you enjoyed remembering that there's a 1 in front of the t as its coefficient, and you found it easier to multiply both sides by the reciprocal of our coefficient. So I'm going to multiply both sides by 3 over 1, and this is going to cancel everything here, and then I'm left with t on the left-hand side. On the right, the 12 and the 3 can cross-reduce. This becomes a 4, and that's a 1. So I'm left with 35 over 4. Now, that's a lot of work. We got lots going on there. I got to use my distributive property, and then I've got fractions going on, and this can become quite difficult. I'm going to show you another way that you can do it where I'm actually going to get rid of all of my fractions right at the beginning. I can actually start by finding the common denominator. If I start with 3 and 4, my common denominator would be 12. So I can actually get rid of the denominator on both sides by multiplying both sides by 12. Because if I was to multiply both sides by 12, and since I'm allowed to multiply and divide in whatever order I like, instead of multiplying the 12 into the brackets, I can divide the 12 by the 3. 12 divided by 3 gives me 4. Now I have a 1 in the denominator, and my fractions are gone. On the other side, 12 and 4. 12 divided by 4 is 3. And again, my denominator disappears. And now all I have is integers. So this now becomes 4 times t minus 5 is equal to 15. Now, don't undo all of this hard work you've just done getting rid of your fractions by now dividing both sides by 4, because then you're going to have fractions back again. So what I would do is I would use distributive property to multiply this 4 into the brackets. Now I have 4t minus 20 is equal to 15. My opposite is to add 20 to both sides. That leaves me now with 4t is equal to 35. And when we divide both sides by 4, here we go. Okay, and that leaves me with t is equal to 35 over 4. Okay. So I didn't really have to work with any fractions until the end. I can get rid of them right at the beginning by getting that common denominator and multiplying both sides by that common denominator. Okay. Now, I will very quickly verify, and so if you need to, pause the video so you can copy it down, because I'm going to try and go quickly with this one. I'm sure you're all done listening to me already, and it's only video 1. This is not going to go well. So we got 5 over 4 on the right-hand side, t minus 5 over 3 on the left-hand side. So this is going to look a little bit ugly because I need to put a fraction into a fraction, and also I have something else going on in the numerator. Okay, so bear with me here. I'm going to put t, instead of t, I'm going to put in 35 over 4. Okay, minus my 5, and then divided by 3. So I'm going to work on that numerator. I've got 35 over 4 minus 5 is the same thing as 35 over 4 minus 5 over 1. Okay, that's the same thing as 35 over 4 minus 20 over 4. And that gives me now 15 over 4. So I'm going to take that and put it back in for my numerator. So now I have this in my numerator, 15 over 4 over 3. And that's the same thing as 15 over 4 divided by 3. Okay, remember the numerator and then the line and the fraction means divide. So I've got my 15 over 4 being divided by 3. Instead, I'm going to multiply both sides. Instead I'm going to multiply by the reciprocal instead of doing my division. And then 15 and 3 can cross-reduce, giving me a 5 and a 1. And 5 times 1 is 5. 4 times 1 is 4. And we have 5 over 4 on both sides of our expression. Okay, so for those of you who are in my D2L shell, I would recommend now going on to page 319 in your textbook. You can find that online on my D2L shell, guys. Yeah, do whatever questions you need to do to practice a few. Don't do all of them, but practice a few. I'll do another video that has some word problems. Hopefully this helps you. If you want to, feel free. I'm going to put this on YouTube, guys. Send it to your friends if they need some help with it. I don't care. It's free for you guys to grab. Good luck, stay safe, and hopefully we get to see you soon.